A very good evening to one and all. Myself S.S. Jugde, and today we are going to understand what is the process of rapid prototyping. This is an advanced manufacturing technique nowadays used widely in the industrial sector. So, what is the rapid prototyping? So, first of all, we just go for the introduction. In many fields, there is a great uncertainty as whether the new design will confirm their actual requirement of the particular customer or not. In the initial stage, before rapid prototyping and development, first of all, trial error method is widely used to design a new product. In this particular case, first of all, design the component, then manufacture it, and then trial it. But nowadays, before going to trial error, first of all, new design will be manufactured using rapid prototyping, and actual theory will be analyzed. So a new design often have unexpected problems. A prototype is often used as a part of the product design process to allow the engineers and designers the ability to explore design alternatives, test theories, and also it confirms the performance prior to starting the production of the new product. So engineers use their experience to tailor the prototype according to the specific unknowns still present in the intended design. So what is rapid prototyping? First of all, we see the meaning of this particular rapid. Rapid means at fast rate. And what is meant by prototype? Prototype is nothing but a duplicate or creating a final replica of a final product having a same dimension with less ratio, with definite ratio. So it is a technique of producing the uh, small part of the actual system to be manufactured. That is what we call as a prototyping. So rapid prototyping is a technology employs a various engineering, that is a computer control or a software technique, like laser, optical scanning, photosynthesis or polymers, material extrusion and deposition, powder metallurgy, etc., to directly produce a physical model. And the physical model can be made by layer manufacturing in accordance with the geometrical data which is delivered from the 3D CAD model. So rapid prototyping is a technique in which we can manufacture a prototype by using a layer by layer technique, for which we get the data from a 3D CAD model. So this is one example of rapid prototyping where this is the Khufu pyramid. Generally, it can be manufactured by ancient time with the human, but in today's world, it can be manufactured like in the process by making a layer by layer formation. So look at this at the initial stage. This is the 30%, 52%, 82%. As the height changes, its percentage goes on increasing. And at the last, the 210 stone layers will be completed with using this particular layer by layer. At the 30% of the work is completed within this particular bottom. So layer by layer completion. So this is the way in new world the Khufu pyramid can be made by rapid prototyping. So before going to the introduction in detail of rapid prototyping, what is the difference between the conventional machining and rapid prototyping? So conventional machining is a process in which process like milling, drilling, turning, facing, etc. These are the conventional machining process in which we can produce a final product by removing the material. So can we remove the material bit by bit, and then after a certain number of operations performed, we can manufacture a final product in case of conventional machining. But in case of rapid prototyping, there is no need to required to remove the material from the actual material, because at the initial case there is no any raw material. In case of rapid prototyping, we have the only a CAD design in case of rapid prototyping, and hence by adding layer by layer we can manufacture a final product. So generally conventional machining is a material removal process, or what we call as a subtraction process, and the rapid prototyping is a generally process in which this process is a layer by layer, that is material addition process. The conventional machining have a limited advantages, but have a rapid prototyping has unlimited advantages and unlimited applications. In case of conventional machining, for each and every defined operation we require a different tools which can support this particular uh, process. But in case of rapid prototyping, there is no such different tools are used. We can manufacture any product by layer manufacturing. So this is the basic difference between a conventional machining and a rapid prototyping. So what is the generally flow of this workflow of this rapid prototyping process? All rapid prototyping techniques employ the basic 5 steps. Number one is you have to create a CAD model in the design. That will be a different. There are different CAD softwares are there like Provi or SolidWorks, normal CAD, etc. So you can be choose a suitable CAD software which can support the rapid prototyping machines. Okay. So second step is convert the CAD model into a STL format, that is standard triangular language format. Which format is supposed to support to the 3D printing machines. So slice the STL file into the cross-sectional layers. For this, construct the model, and that is one layer on the another, and finally clean and finish the model. So this is a generalized process flow chart of or what we call as a workflow chart of a rapid prototyping process. So in this particular case, look at this. First of all, you have to make the CAD model, surface or solid model, that is by using solid techniques or surfacing. Next is pre-process. There are two parts: pre-process and post-process. Pre-process is the process before manufacturing or before supplied to the uh, before going to the rapid prototyping process. So it generates the STL file, builds the supports which is required to need, which is required, and slicing. This particular slicing and again fit to the RP machine, that is a rapid prototyping machine or 3D printing machine, which builds the prototype. After building this particular prototype, you go for the post processing, that is uh, remove the supports, clean the supports, post cura or parts to be completed. These are the post processing machines. So one by one we can see how rapid prototyping is done. So number one is create a CAD model. So creation of CAD model is the step number one, uh, in which we have to prepare a computer aided design model of the object to be fabricated using a layer based manufacturing process. For most of the available RP technologies, we have a solid model with a complete topological and geometrical information is required to create a CAD model. So this particular CAD model is built using a computer-aided design software packages. Then solid models such as Pro engineers, that is what we call as ProE, tend to represent 3D objects more accurately than the wireframe modelers such as AutoCAD, and will therefore yield the we will get the better results. So this process is identical for all the rapid prototyping technique. So second stage, convert the STL model. So what is the STL? STL is a standard triangular language format. So it establishes the consistency. The STL format has been adopted as a standard rapid prototyping industry language This is the second step in which we convert the CAD file into a STL format. This format represents a three-dimensional surface as an assembly of planar triangles. So your CAD model can be divided into a different triangles, and this will be a triangular languages, and it can be provided to the next step. STL files use a planar elements. They cannot represent curved surfaces exactly. Increasing the number of triangles, it increase the approximation. So in case of it is a file available, it is a file format for approximately defining an object using a triangular facts or triangular series. When a CAD model is available, the entire part geometry is converted into STL format based on the tolerance for accuracy control. So this is the example of STL model where this CAD drawing can be divided into number of these particular triangles. This figure shows a typical example of STL model which is composed of triangles, and each triangle is described by unit normal vector directions and their and 3 points, that is XYZ coordinates, 3 points representing the vertices of this particular triangle. So this particular product can be made by number of triangles. So next step is slice the STL file. In the third step, a pre-processing program prepares the STL file to build. The pre-processing software slices the STL model into a number of layers. Slice means cut. It cut the CAD model, this triangular model, in language into a number of layers from 0.01 mm to 0.7 mm thick, depending upon the building technique. This is generally depends upon the what amount of material have to be poured in each and every layer. So program may also generate an auxiliary structure to support the model during the build. Supports are useful for delicate features such as overhangs, internal cavities, and thin walled sections. So these are the desired part or model to be geometry which is going to be produced. So without supports, overhanging areas of the part may peel away the damage the whole model. Look at this. These are the slicing. This can be a CAD model converted into number of slice. This can be process of slicing. After we get the slicing, we go for the layer by layer construction. This is the actual manufacturing process where we can manufacture this particular model. So the fourth step is the actual construction of this particular part. Rapid prototyping machines build one layer at a time from polymers, papers, or powdered metal. Most of the machines are fairly autonomous, needing the it requires the little human intervention. In this particular case, we can, as mentioned earlier, from 0.01 mm to 0.7 mm, we can make the fix the layer size from 0.01 0.01 to 0.7, any type of layer, and this particular layer by layer construction we can manufacture the product. After manufacturing of the product, this is the post process where the it involves the removing the prototype from the machine and detaching any support. So some sensitive materials need to be fully cured before use. So prototypes may also require minor cleaning and surface treatment. Sanding or sealing or painting the model will improve the appearance of the durability. In this process, we thoroughly clean the object and make proper eye visualization for our normal use. So what are the advantages of this particular rapid prototyping? There are a number of advantages for this particular rapid prototyping. That is, prototyping can improve the quality of requirements and specification provided to developers. It reduces the time and cost, because when we go for the trial or error in conventional machining, number of problems we can face after the final product manufacturing. But in this particular case, only one prototype exactly tell what are the small prototype exactly tell the actual product, final product. So it will reduce the time and cost also. Suppose example, in case of manufacturing of turbine blades, in case of rapid prototyping, we can create a prototype which is much more smaller than the actual one. So it will give the same result of that particular actual in terms of efficiency. So it reduces the cost and time also. Users are actively involved in the development, because from many making of CAD file to final product, all users are actively be part of this particular development. They can see, they can observe how layer by layer manufacturing is goes up. So quicker user feedback is quick feedback is available, which leads to a better solutions. Uh, Errors can be detected in much earlier stage, because when we go for the layer to layer manufacturing, each and every stage we get the feedback, so we can easily detect the error. So missing functionality can identify easily. Suppose in this particular rapid prototyping, the prototype gives the actual scenario of our final product. So it will give any part is missing or any functionality can be missing, it will easily indicate. So what is the limitations of rapid prototyping? It has a high precision, RP machines are still expensive, that is cost. These rapid prototyping systems are difficult to build parts with accuracy less than 20 micron, that is 0.02 mm, and wall thickness which is less than 0.5 mm. So if the part is having wall thickness less than 0.5 mm, at that time this will technique will not be applicable. The physical properties of rapid prototype parts are normally inferior to those of the sample that made with the proper materials and by the traditional tooling. Rapid prototyping using a definite material powders, which can be used to manufacture only prototype. But in case of actual component, there are number of metals which cannot produce using this particular rapid prototyping technique. So due to the difference in material properties, there is a chances we go away from the proper result. So RP parts are not comparable to CNC prototype parts in the surface finishing, strength, elasticity, reflective index, and other material physical properties. Because in case of CNC, we achieve the high surface finish due to its advanced tooling system. But in case of rapid prototyping, the layer by layer manufacturing cannot give a high surface finish or strength or elasticity, etc. So these are the some drawbacks of rapid prototyping techniques. So what are the different rapid prototyping techniques? So stereolithography, selective laser sintering, laminated object manufacturing, fused deposition method, and three-dimensional printing. These are some rapid prototyping techniques generally used in day-to-day manufacturing technique. So thank you. If you have any doubt, then let me know. Thank you very much.